basically what we'll do is we're going to take and generate a grid, because Grasshopper will let us generate a grid of cells pretty quickly. It's like 2 component operations. And then we're going to make circles at each one of those center points on those cells. And then we'll adjust it 1 randomly, 2 based on the distance from a point defined. And then we'll begin extruding up those points or those circles based on the distance from this point as well. So you can see how we can begin to take data and actually drive architecture that we're building. Now this is by far not an architectural piece, but it may be, when you'll see how we do it, it may be a wall panel, it may be anything at that sense. You can do fritting on glass if you're doing any rendering. This is a lot of times where I've used this script is for fritting. So it's pretty simple, and it's a good introduction to how we take data and can actually use it to drive things that we want to do, because this is fairly random, and if you were to do this by hand, you could, but you really couldn't iterate through it. So right now I can iterate as much as I want through this piece. Okay, so to get started making one of these, I'm going to keep this open so I can refer back to it. I'm going to go File, New Document, and the first thing I need to do is I need to create a grid cell. So I can do that by going to Sets, go into Vector, and under Vector there's a Grid tab under that ribbon. And I can do all kinds of different grids. You can play around with the various versions of that. For this, I just want to be as simple as possible, and I'm going to do a square grid. Now the square grid is one looking for a plane, and that's going to be the XY plane that we're going to operate on, and I'll just hide that plane. And then I want to determine the size, and then how many numbers X and how many numbers Y. So I go ahead and make a number slider. And I can right click and I can edit that, and I can make that an integer. And I'll just give it a value of 100, so I can use that later on in my sets. And I'll plug all 3 of those into one, the size, how many in the X direction and how many in the Y direction. So I want my size, and I'm going to keep it small for now. The key to this is especially when you're working with gridded systems like this, is to make sure you start out with a really tiny grid and do all of your operations up to the end, and then begin to increase the size of the grid to where you want it to be. Otherwise, you'll end up crashing the computer halfway through your operations, and then you'll probably forget to save, and then you'll probably forget how you got to a point, and then it's all lost, and then you get really frustrated. So really just try and remember to keep everything really, really tiny at first, and then slowly build on that as you go along. So I'll just start with maybe 6 by 6, and that's my grid cell. Now that gives me 1 points and 1 the curve points as well. So if I look at how that's generating and pushing out data, I'll make a curve container, and I'm going to bake that into Rhino so we can look at how it's working. So each one of those becomes its own individual square, and then it's basically just arraying that square around. What I need to do, and then the points, if I look at the point container, it's doing the same thing, but it's also just giving me the 4 corner points of each one of those curves. For this, I don't need to work with the points. I want to get the center points of this entire assembly. So what I can do is go to the curve menu, and then there's this analysis portion. So whenever I want to pull data from an already derived set of objects, it's always under the analysis. And each set has a type of analysis. So surfaces I can analyze, meshes I can analyze. There's intersections and analysis all of itself. Same thing with transform. So really I want to begin thinking how I use geometry to create other geometry, and how it's kind of like a puzzle. How do I leap from one set to another set, and how do I really stumble my way to get there? So in this case, I really just want the center points so I can place my circles there. So I'll go to back to my curve, and I'll go to my analysis menu, and I want to get the center point of my polygon. So there's this polygon center operation that I can use, and that should give me the center points now of each one of those gridded cells. Now, one thing I want to introduce to you is the idea of a list. So when we think of a list, right, I have a container, and in my container I have a bunch of objects within that list. Now, it's possible that we have multiple lists inside of another list, right? So this is kind of what we have going on here. And how I can visualize that is kind of like a tree branch. So if I type in parameter, and I get this param viewer, it'll give me a visual of that set. Let me just make sure I'm plugging into the right one here. So I'm going polyline vertices and edges, yes. So I'm using the edges. So if you think of this as a tree branch, my tree begins with the idea of a center point, and that's that first object. And then each row of this grid, because of the way it's constructed scripting-wise, is that each one of those lines of rows becomes one of the tree branches. So I have one piece, and then I have an assembly of those pieces, which is constructed of 6 rows. If I increase the size of my rows, it doesn't increase the size this way. So that tells me that really my rows are going the opposite direction. If I increase the number in the Y direction, I should get more tree branches. Now that's going to come in later for us. It's important to know and introduce you to it and how it's working. But really, for this operation, I don't want to be operating on each individual row. So when I do an operation, in this sense, if I were to leave it like this, it would only operate on the row. And each piece in that row would be the exact same thing. What I want to do is I want to operate as if this is one giant global list. And it's going to organize itself 1, 2, 3, 4, 5, 6, 7, however it wants to do it. So what I can do is I can flatten what we call flattening the tree. This is a tree. I'm going to flatten my tree. So I type flatten, and I'm going to plug that right into the tree. Now I don't want to connect this and then connect that to my tree because it won't work. This is just like a viewer. It's really just for viewing. It's like a panel. I'm going to plug that right in from my endpoint. So now when I look at that object and how its tree structure is, it's going to be different. It's going to be one single branch, which means it's one single list of data. And that's really what we want. And I can show you maybe a little later if we have time why that's really important and what happens when you don't do it this way. So the next part of this is to actually derive circles inside my cells. And there's a few things. Is one, I don't want my circles to go beyond the size of the cell, right? And I'm going to eventually want to control their radiuses accordingly inside that boundary object. So what I first want to do is just put the circle at each point. So I type in circle and I look at what options are available to me. And I say, well, there we go, circle CNR. Circle created by a center, a normal, and a radius. So that's the most common type of circle you can make in Rhino and or Grasshopper. So I select that one. And I'm going to take my flattened tree. So I flatten my list of data. So 1 is my list, and then 2 is how the container is handled. And then I connect my container of objects into my circle. And that pretty much organizes a circle at each one of those center points. Now I don't have a radius associated with it. So the easiest way to do that is, again, to take a number slider. And I'm going to plug that into my radius. Right? And then it generates my circles on that grid. Now the problem with this is that radius is, again, determined as a radius. Really, I don't want my radius to go beyond the 1/2 of whatever the size of that cell is. So how I can handle that is by doing a division. And I'm going to take whatever this number is, and I'm going to divide that out. So what I need to do is instead of being able to control this by hand, I don't want to have to think about it, right? I want to just do it automatically. So I'll delete that number slider off, and I'll make a panel, and I'll just double click and put a number 2 in the panel. Now it's important not to just hit enter after that, because that space is not an integer, so it won't work. So it's important to only have the integer, no space. And I'm going to connect that into part B. And then again, my grid size cell is determined when I make my grid itself. So I'll take that same number 12 and I'll plug that into my division. So now I have a radius determined for my circle. So no matter how big I make my cell, my circles are going to be stuck to that size. All right, so it's an idea of constraints. Now the second part is, okay, let's say I want to, see, where did I go with the last part here? Yeah. The number 2 is determining, let me just pause this here. So let's say that I want now to generate a random panel out of this. So it's great, I have my circles, it looks good, but maybe I want the sizing of my circles to be randomly sized. So what I can do is, there's a random function embedded in Grasshopper that'll just do it for me. So the first thing I want to do is type in random and start there. And it's asking for a range of numbers. So a range of numbers, if I look and see what it's looking for, is asking for a domain of a random numeric range. So my domain, if I don't know what it is, I would just type in domain and say, okay, what do I need to do? Well, I definitely know I need to construct it. So I want to construct it because I want to have control over it. And then it's asking me in the domain, where do I want to start and where do I want to end? So if we think about this, really that's saying that, how small do you want the circles to be? What's the minimum size? And then you say, okay, what's the maximum size when it goes to the end of the domain? So if we think about that, I don't want my grid circles to be any larger in radius than the size of my grid cell. I plug that into my domain end. So I take that division result here, and then I can take my minimum, and that's really arbitrary. For me, I'm just going to make sure that it's always got some type of radius so it doesn't throw an error on. And then if I look at my panel, what it'll do is it's generating a number from 1 to 6.5. And really that's just the size of my cell divided by 2. So I have numbers from 1 to 6.5. And then I plug that into my range. And then I look at what that's giving me. And it's giving me a random number of 5.24. So right now it's only giving me one single number. And that's because I haven't told the random component how many random values I want from that domain of numbers. And I can have as many as I want. But I really only want as many as I have grid cells. Right? So we know that we created a list of grid cells here. So I can grab the length of that list and it will give me that number of random values. So how I do that is I go to list and see what things I have available to me for the list operations. And I say there's a list length. I say that's what I want. And then I go to where I flatten my list and I plug that into my list length. And if I look at how many values I have, really that list length should be a multiplier of however many this is. So if I have 8, it's taking 8 times 8. If I go to 12, that should be 96 values. And again, I see 96. So that means I have 96 individual cells. That means I want 96 random sizings for my circles. And I'll plug that value into my number. And then what I can do is I'm going to copy this circle over. So I keep my original circle. And I'm going to plug those random numbers now into my radius. And I'll turn off the viewing for the other one. Right? So now I get a random sizing of all my circles. And it's going to adjust based on however much I make the grid. Right? So if I make my grid size bigger or smaller, it'll adjust. Or if I make more or less, it's going to adjust. Now, the nice thing about randomness is sometimes having things as a random function isn't visually appealing. So what we can do is we can adjust the seed value. The seed value is basically your multiplier. So I can scroll through and generate as many different iterations as I want of this random panel. So that's where the idea of iterative design comes in. You set it up so that random design is just generating out design options for you, and then you decide which ones you want to keep or which ones you want to throw away. And then you go back and refine those ideas. Okay? Is there any questions so far? I'm probably going pretty fast. Okay, so what if I have this grid cell, and this is great, it's random, but what if we've all gone to the new Target, right, on State Street, and we look up in the building, Louis Sullivan, is it the Carson building or something? And we see that they have the randomly sized circles that make a pattern right out of the target logo. So how would we go about doing that, since we kind of have that going right now? Is really all that is putting a point object and getting the XYZ value of those points, and then calculating the distance between our existing points and saying that whatever the distance is between those, I want you to vary the size of the circle. So then I get more of a controlled patterning with my wall panel. So what I need to do is first associate myself and find where my point collections are. And since I'm kind of getting a little messy up here, I'll go ahead and make a point collection. And that's going to be my list of points that I've flattened. So I'll bring those down so I can work down here on those. And I can basically just hide all of this stuff. And then I want to have what I call an attractor point. So what we're doing is an attractor. I need to set another point that I can manipulate by hand to determine where I want my pattern to fluctuate from. So I'm going to go ahead and in Rhino, I'm going to make a point, and I'm just going to place it close to the center of my grid array here. And then I'm going to make one other point container, and I'm going to assign this point to that newly created point in Rhino. So I right click, and I say set one point. And now I have my point collection and then my attractor point. So I want to calculate now distances between all of those in the XYZ. So what I can do is just type in distance, and it's going to say what's my point A, and I'm going to make my point A the attractor, and my point B is my point collection. And if I make a panel so I can view what data I'm having, you can see I have a list of values I'm associated with whatever that distance may be from my point collection. Right? And if I take my original idea of making circles at those points based on radius, right, I'm going to take that circle operation, and I'm just going to simply place in that distance as my radius. And you'll see I get a very large set of circles. And that's mostly because that distance is too large of a value to actually conform itself into my gridded array. Now there's really no easy way to get it to snap always to that grid cell size like we were doing before. So what I do is I just manually do it, and we use a number slider, and we think of it as like a threshold idea. So I Control C and Control V for another number slider. I'm going to paste that into my, actually what I need to do is now take this distance, and I'm going to divide it by my threshold value. So I'll take divide, division, take my distance value divided by my threshold value, and I'll place that in as my radius. So now I have control over how much or how little that spacing is. And if I move this point, my grid cell now reacts accordingly to that. Now, maybe I want more of a variation or less of a variation. I can take that same idea of a threshold and I can do a multiplier with it, and I can get a little bit more fine-tuning of that value. So I'll plug that into A, and then I'll do a new number slider as a kind of like a reduction value, and that'll be a decimal value. And then I'll plug that into my radius. So now I can adjust accordingly by that. Or I can even go higher and say I want it times 2. So maybe I'll adjust it so it's a little larger. Go all the way up to 10. Right, so I can adjust it that way as well. So now we've got a random function. We've got a function based on distance from a point. What I want to do is begin making actual panel geometry, because really at the end of the day I really have to have something that I can visualize. Right now I really don't have anything I can visualize. It's just a set marker of data. So the first part is if it were a wall panel, let me just double check myself for this. really, if it's just a wall panel, I want to assemble all of my curves into the same part. Now, it's not really easy to trim things when they're surfaces, so I'm going to try just doing a boundary surface, and that's like your planar curve operation. So I do boundary surfaces, and I have this collection of circles, and then I also have my collection of cells. So what I want to do is I want to combine those into the same container. So what I can do is go to curve and make a curve container, plug in my circles, and then I'll also plug into my flattened list of cells. And it's throwing an error. Oh, that's a list of points. So I'll do this one. Sorry. Circles there. Gotta go all the way back to this one. So see, I never flattened those cells. So these cells still exist as this tree branch. So what I'll need to do is actually flatten my curves. So now I have a same collection as I do here. If I were to make a parameter viewer, those branches would all be in one list. I'm going to go ahead and disconnect all of my objects from that. Place my assembly data into there. And then it should make cutouts for my panel surface. Right? So that's your planar surface operation. And now if I adjust this, it should automatically be filling in my surface. Now you'll see, you'll have to adjust those threshold values that we set up once you get the matrix a little larger or smaller accordingly, because it goes a little awry at some point. Once you get more advanced in setting up rule sets and things like that, you can control that a little bit more. But I tend not to get that deep into it, because really I just need it to generate what I want, and then I manipulate it the last 5%. So that gets us into really into the idea of list and data-driven architecture. A few other things is, now I want to maybe extrude my circles up based in height based on that same distance calculation. So what I'll do is I'll remove my curve data there, so I only have circles now. And I'm going to reduce the number of size so I don't crash my computer here. I'll crank up my threshold so they're a little bigger so I can see them. And then I'll take those surfaces and I can do a simple extrude command. And you'll see it should extrude them up. Now I have no direction. So direction now is again a vector. And a vector's got, in the sense of Grasshopper, is really a direction and a magnitude at the same time, if we remember that from last week. So what I can do is take that same idea of the distance calculation and use that as a height driver for these objects. So what I can do is say I want to go one first in the z direction, so they go up in space, and then I need to give it magnitude. So that magnitude will be calculated based on that same distance calculation, which was here. So instead of making a circle with it, I'm going to use that same the same radius value as my height value. Right? Now if I want them to go bigger or smaller, again, like we did a threshold, I put in a multiplier. Oop, wrong one. I want a whole number. And I say whatever that random value is, or distance value, is going to be now multiplied by a certain value. And now I can adjust that, the magnitude of that extrusion. And then if I move my point, it should grow accordingly how I want it. Now let's say combining everything else that we've just done, it is really, I want to have the height grow based on the distance from the point. I want the radius of the circle to grow based on the distance from the point. The last part is then I want to randomize whatever that height is. So I keep this idea that everything is growing, but I still then want it randomized, kind of like a city is laid out. So what I can do is in that extrusion value, as I need to now take my old random function, and it's as simple as just copy. Since I've already made it, all I have to do is really just copy this down, or I can use my random function already made, and instead of doing my multiplier as a defined number, I should be able to just plug that in to my multiplier as it is, and then I have a random sizing and a growth. And I can continue on and on and on and on and on with this and do as many multipliers or divisors as I want with it. You know, you can really begin to get advanced, and we'll get into this next week and start plugging in math formulas into it. So we'll have waveform surfaces based on some cosine value or sine value. You know, and another thing I can even think about now that I have all this data, right? I know I can deconstruct this geometry and get different height values and construct a new surface out of that. So the last part is, since we kind of made through this pretty quickly here, I'm going to try and get the tops of those centers of those points for you. And then we'll generate a surface from that. So what I can do is I have my extrusion, and then if I go to my surface menu and analysis, I have my B-rep wireframe, or edges. I'm going to hide that. I'm going to hide everything else I've done up to here. So you see with the cylinder how that works with the circle. I have one line, the base, and the top. So each one of these I want to make a curve container to see which ones I want to work with. So I have all of those. Okay. So really we're working with the interior curves. And if I look at my parameter viewer, really I want only the top portions of that. So each one of these, and this is getting into next week's stuff, each one of these is a separate list container, and it has 3 pieces into each object. So what I want to do is actually pull out the data from each one of these top portions. And what I can do is do a cull, just like we culled our degenerate faces. I can do a cull index. And here's my list of data. And if I look at my list, it's always the number 2 item. It's either 1 or 2 that I'm pulling. I have a line-like curve and then 2 circular curves. So I'll make a number slider or copy one I've already made. And that's my index value. So you'll see it selects everything but, or everything, and removes essentially everything but the ones I want. So we'll maybe, let's see, so we're going to remove number 1, and then we're going to cull another one from that culling. And we got, let's see, 1 and 2. So there we go. So that gets me to, I've just disassembled that list into one piece. And then I can get my polygon center from those curves. It's kind of a long way to go about that. Oops. So if I use my analysis, right now the polygon center is not working because the circle is not technically a polygon. So I need to figure out some other way to get the center point of that. I guess what I could do is probably do the control point, which is not the right one. How's it going? How would I get... So this is where it's a puzzle, as I need to figure out how to get that point really easily. Okay, so that got me my endpoint. Good enough. I'll use the endpoint. So that's a height matrix. I have that collection point. I should be able to construct a surface now based on those points. So I have a surface from points. And if I go to here. Nope. What about there? Ah. So it's looking for a number in the U direction. I give it a number if it's what it wants. And what about there? Okay, so we'll pick up there next week. So I got to go through and figure out how to get that to read. But basically, we can begin actually warping surfaces and really constructing some freeform geometry. So I already have this Grasshopper file for you. It's already done. Everything we went over today is more organized, so there's notes in that Grasshopper file too, so you can literally pick it up and go play with it. So as soon as the video is done, you'll have this video and the Grasshopper file, and I'll finish up last week's as well at the same time. So really, I want you just to be having fun with this stuff. This is the fun part of this semester. So, okay. Is there any questions about what we did?